actually sure this is recording. Is it? I certainly hope so. Yes, it's being recorded. Well, that's going to sound like a really funny intro. I'm sorry, because we're not going to edit that out either. So, welcome back, my friends, to the show that never ends. This is your Tuesday night edition of the Professional VMware vBrownbag. Tonight we're talking about Google Cloud, or kicking off our Google Cloud series. It's the first series that we are doing that explores things outside of our traditional VMware and lightly OpenStack roots. We're going to be talking with Terrence Ryan about what is the Google Cloud. So here we go. Before we get too deep into things, we do have quite a bit going on around the vBrownbag community at pretty much all times. Last week, if you follow me on Twitter, I was rather freaking noisy about the work we were doing at the OpenStack Summit last week. It published 85 some odd videos during the week. If you get bored at work, go ahead and view those. They're all at they're at one of these many URLs here on this particular slide. We have APAC, EMEA, Latin America, and the US brown bags, each covering their own different. In fact, I should have that in front of me when I'm talking here, right? It'd be helpful if I were a good host. I've done these things ahead of time, right? The EMEA podcast is doing VCP network virtualization. The US podcast is doing data center virtualization. Let's see. APAC is having storage debates, it looks like. I'm not sure how recent that is. And then the Latin America stuff is all in Spanish, and they are also covering the VCP network virtualization bits. With that, I am your host, Cody Bunch, and on the line we have Terrence Ryan. And I'm going to go ahead. Where's this button? There you go, Mr. Terrence. You should now be the presenter.
Okay, and you guys should now see my screen. So
Maybe?
I will.
There it is. Yes.
Yep. All right. Great. And I will try and keep track of questions on both. I'm going to try to do something I haven't done before, which is leave a Twitter client running Dora Prezzo, because I know you guys will occasionally chatter on the vBrownbag hashtag, so I'm going to see how that works out. It's good that if anything goes really wrong, this is being recorded. That makes me happy. So I'm going to go with slides here, and can you guys see?
Yep.
Yep. And do you guys see the GoToWebinar control panel? Do I need to close that down, or is that only on my screen?
I don't see your control panel. I see my control panel.
Awesome. Okay. All right, so this is an introduction to Google Cloud Platform. My name is Terry Ryan, and I'm a developer advocate for Google, specifically on the Google Cloud Platform team. I normally try to do a poll of who you guys are, but I don't think I can kind of do it with this format. It's fine. You guys are mostly developers, from what I understand, maybe some system people, and that's sort of the background. So I'll try to keep this more technical than talky, but I am going to present some things to sort of tell the story about what Google Cloud Platform is. So I do work for Google, and whenever we sort of mention Google, we kind of evoke this, right? This is what we're known for. I like to call it, because I don't work on the search team, I can call it without hubris, the dial tone of the internet. Basically, when people want to know if the internet is up, they use us, and basically we're that answer to, are things running? Yes. And the way we do this is all of this is powered by a really incredible infrastructure. Basically, we told the guys, or the search team said, go out and build like a lot of infrastructure, and then they kept building and they kept building and kept building, and then they sort of forgot to tell the guys to stop building. And so we have sort of a giant infrastructure at our beck and call, which is kind of helpful, because when someone comes along and says, and way back 10 years ago, and the idea of having free email that wasn't terrible and was a gig was sort of revolutionary, there were a lot of reasons why it might not have worked, but the infrastructure couldn't handle it was never one of them. Same thing with maps. Like, hey, we're going to take a picture of, I don't know, everywhere, and then put it on maps. That's sort of what we call moonshot thinking. Is difficult. It's certainly challenging, and there can be a lot of things can go wrong with it. But we like to think that we have crazy ideas like this, like let's take a picture of everywhere. We might run into privacy laws and other issues, but the idea is the infrastructure wouldn't be able to handle it. It's just not something we ever think about. And so in order to build that infrastructure, in order to maintain that infrastructure, we build a lot of tools. We built tools that then use those tools, and then we built tools on top of those tools, all to manage, the giant number of servers and disks and everything we have going. And we kind of like what we have. We certainly like it internally, and we had the idea of like, wouldn't it be great if we could, sell this stuff, if we could turn around and share it with other people so that other people could build their tools and technology on top of our crazy infrastructure. So that's sort of the background of what Google Cloud Platform is. It is basically a fleet of tools and services that allow you to host your work on our systems. So I'm going to give sort of a 30,000-foot view tour of this, and just sort of kind of explain where we're coming from. So you want to take on cloud services, then you're going to have to run some code, and if you're going to run some code, you need processors to run that code, and that's kind of provided by our compute stack. We have a couple different options, from all the way from you just give us code and we run it for you, platform as a service in Google App Engine, to we'll just give you VMs and you do whatever you want with them, obviously within reason. And that's Compute Engine, and then we have Container Engine, which allows you to spin up huge numbers of containers using Kubernetes, and we have managed VMs. We have a whole lot of technology around computing, but this is basically the core of it. And next to that, we have a whole bunch of storage options. We have, if you need to store flat files or images or giant binaries or whatever, it's just file storage, we can handle that for you. We also have a SQL solution, which is based in MySQL, allows you to run MySQL solutions like you would sort of expect. Then we've got two NoSQL solutions, a sort of a flat document based NoSQL solution, and then a giant columnar database that we call Bigtable, which I'll actually talk a little bit more about in a minute, or a couple minutes. Backing all this up is our infrastructure, our network. Basically, it allows you, if you want to hook up your network to our network so that you have a VPN connection between your stuff and our stuff, we can accommodate that. We've got load balancers. We've got basically everything you need at the networking level, everything you'd expect in the sort of offering. And then from the big data perspective, and this is now where we get to tools that are written on top of tools that are written on top of tools, we have a number of things that allow you to analyze and move data around and really get into the nitty-gritty. And like we have, like if you are a genetics researcher, you can use your genomics big data product to really go deep into sort of genetic information. Backing all this up is obviously things like management tools and developer tools. And then we also have something I'll talk shortly about called Firebase, which is one of our mobile solutions. So great. Did I hit all of the cloud bingo buzzwords, right? I did. Let's see. I said NoSQL a number of times. I don't know if I said DevOps. One of my coworkers really likes me to say NoOps. I've been resisting it, but it's on the card. And I joke about this stuff. I joke about cloud bingo, but at a certain level, there's sort of a serious truth here, which is that in order to know whether or not you can run your systems or your apps or whatever you want to run, you have to know that we have a minimally viable platform for you, so that if you are in the business of storing large amounts of data for your customers, then you need to know that we have a large storage solution that can handle that for you. If you need to host terabytes to petabytes of image files, and that you need users to get at them and see them, you need both that hosting and also CDN services around it, right? So you need to know that we have all this stuff, and we do. But you talk about us, Google Cloud Platform versus hosting on premises versus hosting it with other solution providers, and you really have to sort of ask what's the difference. And at a certain level, at a big, 30,000-foot view, there isn't a lot of difference. I mean, I can go into, well, pricing might be better for this, or we have a couple features here or there. But at the end of the day, at the 30,000-foot view, pretty much anything you can do on our platform, you can do on-prem, or you can do with another provider. What I need to do, my job, is to take all of this stuff, all of these things that all of us provide, and really highlight the places where we are different, where we provide value that no one else does. And that's sort of what I'm going to do here. And I'm going to do that instead of picking, instead of trying to give you the auctioneer's list of every single feature that we have, I'm going to talk about and demonstrate 3 to 5, depending on how I'm doing on time, of these services. So here's the whole big Google Cloud Platform. I want to talk about 3 services that we have. First one being App Engine, which is our platform as a service. One being Cloud Storage Nearline, which is a sort of feature of our storage tools and technology. And the last one being BigQuery, which is sort of one of our, it's our big data, one of our big data analysis tools that can really do some pretty cool things. So with that, I'm going to just jump into App Engine. What I'm going to do is I'm going to talk about it, explain what it is, kind of talk about some successes we've had with it, and then show it in action. So App Engine is our platform as a service. And what do we mean by that? We mean you give us code, we run it for you. You don't tweak hardware settings, you don't see processors, you pretty much don't deal with hardware at all. We will run the code for you. We will provide services for that code. So, for example, if you want to send mail, we have an API for that. If you want to send, you want to do network traffic, we have an API for that. If you want to, use caching, we have memcache built into it. And you wouldn't necessarily have to configure any of these things. You just use our APIs and go with them. And in return for using those services, you get auto-scaling. And this sort of makes sense, right? So you give us code, and we're going to scale it out as wide as you need it. So to do that, you can't be writing to the disk, right? Because if you're auto-scaling, the idea of a disk just sort of kind of is a giant problem, right? You can't write to local disk, but you can write to Google Cloud Storage, which is part of it, and we have APIs that make that fairly easy to do. It supports out of the box Java, Python, PHP, and Go. If you are not using one of these languages, today you cannot use App Engine. However, there is a sort of there's a beta technology that we're moving pretty quickly on. It's pretty cool. It's called Managed VMs, which sort of allows you to do some of that with custom runtimes. So you would be able to support whatever language you want, but it is in beta, and I'm kind of talking right here about a service that's full availability and has full SLAs. I want to stick with App Engine for now. Let me talk a little bit about the power of App Engine. In terms of monthly requests, or number of times a month somebody asks for content from a site. Your average server out there on the internet that's serving for your average company, it's not necessarily it's used but not necessarily crazy popular, just normal active use. We have about 86 million requests per month. That's you can kind of look at that as like a sort of average baseline. If your site is hot, if you are getting a lot of traffic, if you are one of the top 500 sites on the internet, you're maybe getting 500 million requests a month. That seems sort of reasonable. Maybe not top 500. It's probably a longer tail than that. But you have the idea. You've got a site that's really hitting. You're getting about 500 million requests a month. If you are Wikipedia, you are getting 2.6 billion requests a month for various things on your site. And then next I'm going to show BigQuery. I'm sorry, not BigQuery, App Engine. We'll show what App Engine is doing in a month. App Engine is doing, it doesn't fit on the screen, App Engine is doing 28 billion monthly requests across all of our properties that are running on App Engine. So that's the type of scale we're talking about with App Engine, sort of a monumental amount of traffic. I want to talk about a little bit of that traffic. I don't know if you guys are familiar with a casual game called Song Pop. If you're not, please don't research it while I'm talking. I sort of like when I was giving this talk, I was like, I should play Song Pop just to kind of remind myself of what it's like, and I fell into a gate hole of playing Song Pop for like 2 hours, and then had to kind of get out of that and prep this prezzo. Song Pop is basically name that tune for the internet age. So basically, you go up against other players, and you get a tune and song, and you basically have to identify it before your opponent does. It's really addictive. It's really kind of cool, and so it's a casual game. And it's important when you start hearing these traffic numbers that it's just 6 engineers. 6 engineers decided to get to put this product out. So they launched back in May of 2012. And by July of 2012, they had 100,000 daily active users. That means 100,000 people were using it every day. And at this point, they decided, hey, we should probably have a support account with Google, which I find hilarious, right? Like they had run this business, and they're like, oh, maybe we should pay for support, like 100,000 daily active users in. But what I love about that is that basically they were self-serving themselves. They didn't have any support. They were just using our documentation and our basic tools without any sort of tuning or tweaking, and they got themselves up to 100,000 daily users in 2 months, which is ridiculous. So flash forward another 2 months, July, August, another 2 months to September, when they hit 500,000 daily active users, and they had to tweak a little bit. So they had to tweak their caching model and their data model just a little bit. They didn't have to add any service or anything. They just had to basically use what we had there. They had memcache available to them. They tweaked their memcache setting, and we set a couple of quotas a little bit different. And but for the most part, they were fine to 500,000 daily active users. And then by February, they had gotten up to, or December. Part of my screen is obscured, so by some point they got up to 1.5 million daily active users. I think that was December, and so basically they in the course of 7 months, they went to 1.5 million daily active users. At that point, they had to tweak their indices a little bit, but they were basically able to support that load in a very short period of time. And with that, I'm going to switch to demos. I'm also going to hide this. I'm not blocking that anymore. All right, so let me show you a demo of App Engine in action. So right here, I have various control panels of App Engine open. Okay, so let me just walk through real quick what we're looking at here. So this first is the App Engine dashboard. So I'll launch it, and you'll see that right now there are no instances deployed, and that's a really important thing about App Engine. If no one's using it, then you're not being charged for it. So which is kind of nice. And what I'm going to do is I'm going to, let's see here. I'm going to show you some code real quick. Here we go. So here is a this is hello vBrownbag. This is basically just some PHP code, right? It's not too exciting what it's doing, but basically what I'm doing is I'm creating unique file names, and I'm writing them to Google Cloud Storage. And I noticed if you guys use PHP that this isn't crazy PHP. The only thing that's a little bit different is that you're using a URL that's GS instead of HTTP or FTP or any other thing. Basically, this allows you to write to Google Cloud Storage just like you would to a file system. And so what I'm doing is I'm coming up with a unique name for a file and writing it the same time that I say hello brown bag. So what I'm going to do here is I'm going to publish this code. Actually, let's see. I'm going to try to pick a random word. This is dangerous, but I'm going to random word generator. Random word generator. Let's see. No, is it just saying hello? That's not really that helpful. That's not really that random. All right. I want to pick the word brainstorming, just to show you that I didn't do this ahead of time. Brainstorming. Sort of random message there. All right, so I'm going to take this and I'm going to load it into the cloud. Here. And app big deploy. Oh, sorry. So, sorry, it's update. The tools have changed. I'm using the newer version that's not publicly available yet. There we go, update. So basically, I took those files, I loaded them up, it's starting deployment, and done. All right, checking if it's successful. It says it's successful. Great. So now, if I go back here and I click on instances, we said before there were no instances running. Because it checked to make sure it was running, there should be one. Oh, no. So there are no instances running. Cool. Great. So now I'm going to click on and load this, and you'll see hello vBrownbag brainstorming. So it's now live, and you can hit this URL if you want to get this, crazy message. But what also happened here while I was doing that is, let's see, I've got the log view. I'm going to set that to do a live stream of the logs. And we'll see that my request, if we look down, we'll see that this request caused a new process to be started for your application. Fair enough. So basically, it launched a new instance. So now when I go and look at the dashboard, there's usually a little bit of a delay here on number of instances because usually you don't need it in real time. But there we go. It launched an instance. We can see that running, which is great, but not really that exciting, right? I mean, yeah, great. We fired up something. Also, we wrote some log files here. I'll look at logs. Let's see. Oh, well, a whole bunch of you hit this, I think. Cool. Okay, good. I'm going to delete all these because this works better if this is empty. There we go. Some people are still looking. Cool. That's fine, but we see that I emptied it completely. Because what I'm going to do is I'm going to launch another product that we have, which is called Container Engine. I'm not going to go too deep into what it's doing. But basically what I'm going to do is I'm going to launch a number of helper nodes, and they're going to basically pound this thing with traffic. I think what I end up doing is I create 10 containers that have 100 workers each, so I have 1,000 workers that are going to hit this site every 100 milliseconds, right? So I'm going to send a fair amount of traffic. This basically is a tool that one of my coworkers wrote to sort of test this stuff out, and it ends up, he basically designed a DDoS machine. It's sort of a great thing to use to test App Engine with. So I'm going to run a script here that's basically going to do that launching. And again, you don't really need to know what's going on here except for the fact that I'm basically launching up a number of services on a container engine and having them fire traffic at that site. So now you see the virtual devices are running for 100 seconds. So every 100 milliseconds, it's going to run a request. So if we go here to the log viewer, which was running live, we'll see that no new entries were found. We're not getting traffic. But if I look over here, let's see, if I look over here in the file system, we should see that files are being written pretty quickly. And as I keep scrolling, they keep coming, because if I look at the log viewer, now all this traffic, interesting, with the live stream. There we go. All right, and we see all this traffic is coming in. At the end, we'll count up all the traffic. But what's really cool here is, first off, I go here, and there's no lag. It's up and running. At the same time, though, if we look at, let's see, where's load? Let's see, instances. Yeah, we look at instances. we should see that a whole crap load of them fired up. Let's see, how many total is it reading right now? It's reading 60 instances to handle that traffic, because they am sending a fair amount of traffic at it. So you'll notice that I didn't configure anything crazy. I didn't tweak anything. Basically, that was the basic App Engine install, right? It went from 0 to handling the load of all these devices pinging at the same time and writing the files. And it did it without a noticeable delay in any sort of request. So we go here and request. We'll see, boom, hello, brainstorming. So if we look here, this should run for another couple seconds. You'll see, great, it's shutting down. And while this is shutting down, I'm going to run another thing, which is to run counts. So we find out how many requests total, and the way we find that out is by counting all the files that are in that. It takes a little bit because I'm remotely counting them. But long story short, this demo, when we first started writing it, we accidentally set the numbers too high. So we set the numbers, so I forget how many, you're going to get like around 70,000 requests total came in 100 seconds. But when we first run it, we accidentally set the numbers too high and set about 16 million requests in those 100 seconds. And it worked fine up until a point. And then we started getting quota errors. So basically we were over quota on how much usage we could have, which is it's sort of a nice feature, right? Like I basically, I did the equivalent of like, hacker newsing or fireballing or slash dotting, whatever verb you want to use, our App Engine account here, and it ended up we ended up not like running up massive charges because eventually the quotas kicked in and stopped the throttle up. Now, that was 16 million requests in 100 seconds. For this one, we didn't even get close to it. We only got like 61,000 requests, and we wrote less than a meg to Google Cloud Storage. But we did all that, and again, we did all that, the logs are just pouring in. We did all that with the base install of Google App Engine. That's like the real important thing. We didn't tweak it, and just that is Google App Engine in action, scaling to take all of those hits. And this amount of traffic, this little peak is nothing. Like basically, this doesn't run afoul of any of our quotas or anything. Like I can handle this day in and day out. And what's cool is if we go back here eventually to instances, we see that it's dropped down to 60 because the load has gone down. As we get a little bit further away, this load will keep dropping until it gets back to 0. And the cool thing here is we will not be charged for any of that once it drops to 0. And we'll only be charged for the minutes we actually ran. So really, really kind of great model here of you can scale, if it's not being used, you're not getting charged. And if you do get heavy usage, we're only going to count that usage when you're actually using it. You're not spinning up machines that then stay idle for a while. So that is App Engine. And I'm going to shift gears a little bit. I'm going to first make sure that no questions have come up or anything. Okay. No, we're good. All right. And then I'm going to switch and talk about something a little bit, maybe not as overwhelmingly sexy as scaling massively. I'm going to talk about cold storage. But you'll like the story. So we all, from time to time, have to store stuff for long periods of time, right? We have to store backups, we have to store archives for accounting purposes or for regulatory information. There's all sorts of reasons why you keep data for a long time. But we hate this data, and we don't want it, and so we sort of treat it poorly. We kind of say like, oh, well, you know what? Like, if something goes wrong and we need this, we're never going to need it, right? And so we put it in what we call cold storage, which is data that's not easily accessible. You can get to it, but it's going to take you time to your first byte, right? You're going to take you time before you can start running it. Maybe this is by using some sort of media backup, that you're actually storing media somewhere in your locale and putting it somewhere. And so that media usually has, you have to retrieve it. If you're lucky, it's in some sort of automated thing where you can just sort of retrieve it quickly. But most time, like, you have to go to a closet somewhere, check some numbers, pull some media, bring it to the media reader. You know the process. You could go with one of another cloud provider. There are a couple of cloud providers that have this sort of cold storage, but again, they have this deal of like, we won't charge you that much for it, but we'll keep it, and you get charged a little bit, and if you need it, we'll charge you for it, but it's going to take you time to get it. This is great until you actually have a problem where you need to either retrieve a backup or you need to deal with a regulatory issue. And then you will find that your user base who has come to you and said, we need this restored, will sort of change their tone towards you. Because you said, hey, it's great, I get this great deal, it's not going to cost that much, but it takes a while. And of course, when you need the data, you actually really, really need the data. So our solution to this is cloud storage nearline, which is based on the same technology. You use the same tools and technology that I was showing you with where those log files were, but you can store stuff in cloud storage nearline, right? The idea is that it's not as fast as online, right? You don't immediately start getting it. It's not sub-second access to it, but for half the cost, it'll start coming down to you within a couple seconds. So instead of having to walk somewhere and grab media and put it in, this can be your solution. You store it nearline instead of storing it offline. What's great about this is, like basically you normally have to make a compromise that if I want it cheaper, I have to take a lot more time to have it go. Here's a case where the compromise is you just get to have it cheaper. Like, that's sort of great. I think those sort of compromises where you actually don't really need to compromise. So that's Google Cloud Storage Nearline. As far as we know right now, nobody is offering a comparable product. That may change, obviously the market being what it is. But it's just one of those places where we just have this little edge where we can give something that you don't normally see in this environment. So I talked about computing, and I talked about storage. I'm now going to move on to big data. So I'm going to talk about BigQuery. Sort of name's a little bit on the nose, but it's pretty cool once you see it. So let's talk about big data, right? You have terabytes of information, and you want to do some analytics on that. How are you going to go about doing those analytics? Normally, you're going to spin up some sort of Hadoop job and run MapReduce over many, many sets of data. You're going to spin up all this infrastructure to manage that, so you can have the nodes to split it out into multiple nodes, so you can split the work among all these machines. The idea that you would just fire off, like, go to your favorite SQL tool and just fire up a couple of query, SQL searches on this is sort of crazy. BigQuery sort of would tell you, no, you're not crazy. You can have that. BigQuery allows you to scan terabytes in seconds, and you can do it using a SQL-ish query language. Now, I say SQL-ish. People ask, well, what do you mean by SQL-ish? I mean this, that if you're a reasonable person like me and you look at it, you'll say, that looks like SQL. But someone may come along and say, like, well, actually, in 1992, the ANSI committee met, and they said that this, all right, look, I don't even want to get into that. Fine, it's SQL-ish. It's close to it. You're going to look at it and say it's SQL. I'm going to look at it and say it's SQL. There are some cases where, certain operations aren't supported yet. But for the most part, you're going to be able to do this stuff with a SQL-like syntax. The UI for it is, the APIs for it are, there's a REST API, there's a web UI, and you can hook up ODBC to it. Now, before you do this with this, though, you should keep in mind that while it's fast for scanning through terabytes, it's not, run a web app off of it fast, right? This is still for offline data analysis and not necessarily for real-time answers. But let's kind of show the demo and see this in play. So I'm going to go here and launch BigQuery. And I have a number of data sets already set up. So here is Wikipedia. So remember I said Wikipedia got 2.6 billion requests a month? Here's where we get some of the numbers from. Anyone can do this. Wikipedia has every request that comes into Wikipedia archived, and you can just download it. And what it is, it's a series of basically three answers. I'll show you the data. Look at the details. You'll see that there's a source, there's a title, there's the number of requests it got, and the size. And the files are broken up by hour. So every hour, so for example, like, let's see, the German version of 1799 got one request in an hour. Maybe it got one request each hour. And so add it all up, it comes to 24. Basically, all of these log files are all separate, and you can pull them down, and this is what the data looks like. So you'll see that I have here the usage for this is 2015, May 1st, okay? And the table size is 11.7 gigs, and the number of rows is 186 million. Right, so if you're looking back and you're thinking about MySQL or some other SQL solution, this is a sizable database. This is a large database that you would look at. So I'm going to go and query this, and I'm going to cheat. I have some of these queries written already. Let's see, here we go. So I'm going to use this one, and I'll basically walk through, and you'll see, like I said, this looks like SQL. I'm basically saying, give me the sum of requests, basically give me the top 100 requests, titles by request. So add up all of the requests per title and give me the top one. Also, I'm being a little English-centric here, and I'm saying the length has to be greater than 2, because there's a bunch of system pages that are frequently hit that are less than 2 pages, and that's not really meaningful data. So I'm going to run this. We'll see on May 1st, what were the top 100 pages in English that were requested. If I run the query, you'll see that it ran really fast in 0.5 seconds, because with cache, that's not fair. So I'm going to go through and I'm going to turn off caching, and I'll hit run query. But it's cool that if I already did this query, I don't have to worry about it again. Like I can reuse the cache data. And I tested that earlier today. So it's stuck around for a while. So it actually ran in 9.8 seconds, and it processed 10 gigs. And I get the answer that on May 1st, the main page was big, which makes sense. Malware was big. Academy Awards were big. Two-dimensional nuclear magnetic resonance spectrography was big. And then number 6 was Avengers, which sort of a big range of interest. Actually, if you draw a Venn diagram between those two, I would imagine there's a fair amount of overlap between those two topics. But that kind of just shows you what was big on that day. And that took me, 9.8 seconds. So I'm now going to go to usage. You'll see the file is 2015-04, or everything in April. And if I click on it, you'll see, if I describe the detail, you'll see that it is 335 gigs and 5 billion rows. So we're going to run that. I'm going to run that live. This took 10 seconds to take. Let's see how long this is going to take. I'm going to estimate it at 14 seconds. I could be off. No, well, actually, what? No, I'm sorry, I didn't change it. All right, that was really fast. Sorry, let me run that again. I'm going to estimate it at 14 seconds. Let's see. It's running. Let's see. We'll see how many rows it went through. Let's see. Oh, okay, only 8 seconds, but it processed 294 gigs in 8 seconds, and we got Academy Awards were still big. vBrownbag was big. Let's see, kernel density estimation, Alligator, Furious 7, Avengers, Age of Ultron. So, okay, for April, it makes sense these things were big. All right, cool. Let's go bigger. Let's go usage for 2015. So this is January, February, March, and April of 2015. We get 1.28 terabytes of data, or 21 billion rows. If I then run this query on the same thing, what is that? That came in a lot faster. It came in 8 seconds. I'm going to give this one 14. I'm going to say this one's going to take 14 seconds. I'm willing to have dead air. No, I'm talking over it, but I'm willing to have dead air here to show you that it doesn't really take that long. It took longer than 14 seconds, though. It shouldn't take longer than 20, though. Unless something goes, oh, there we go, 20. All right, so in 20 seconds, I processed a terabyte. And we see Academy Awards are big, malware is big, Lieberland was big this year, Script Kiddies, astrology, deaths in 2015, Slack was big. All right, so we kind of understand. And so we're running these queries on data that's that big, and we're doing it that fast without spinning up large amounts of clusters and Hadoop nodes to process this. So this is really powerful, and it allows us to do something with big data that we don't normally do, which is sort of play around with the data, right? Because it's so expensive and onerous to sort of play around and ask sort of ad hoc questions of big data because you need to change the whole thing and need to do everything. We don't do it. But what if we could ask trivial questions of this data? So I'm going to ask a trivial question. And again, I've already done it. Basically, I have a bunch of demographic data on that's tied to Wikipedia articles. So basically, I can link people's names, places of birth, date of births, nationality, gender. I can link all of that to Wikipedia's logs, and I can ask, all right, who were the most popular actors? And it's okay. This set of data doesn't see a difference between an actor and actress, right? Actor is the profession, gender is irrelevant. So I can basically ask who were the top 100 actors as determined by searching on Wikipedia, which frankly is the only real measure of any success, that people are looking your info up on Wikipedia. So I should have stopped talking and sort of run this query. This is going to take about 40 seconds because it's joining a whole lot of data. But if you think about it, taking a terabyte of data, joining it to, what am I joining it to? I'm joining it to so I'm joining a terabyte of data to only 36 megs of data, only 450,000 rows of data. But I basically am asking a trivial question: who's the most important actor on Wikipedia in 2015? And I'm going to, like I said, I think the answer is going to come in 40 seconds, so I'm going to talk up till that limit and see just how well I did on estimating it. Nope. All right, so it's going to keep going. Oh, 42. 42. I should have gone 42. Life, meaning, everything. All right. So who do we got? Who are the most important actors? And I apologize if any of this news makes you question the decline of Western civilization. But the top actor is Kanye West, followed by Paul Walker, and followed by Taylor Swift. So this is the people that are most being searched for. Dakota Johnson, obviously, for the 50 Shades of Grey movie. Bruce Jenner for everything he's done, another 50 Shades of Grey. So this makes sense of who would be the top, 100 actors. Elvis Presley, Leonard Nimoy, who passed away during that period of time. Unfortunately, it's sad. You look at this data and you can understand all of it, which is disturbing. But yeah, so very quickly I was able to get the answer to who were the top 100 actors from Wikipedia using BigQuery, using a SQL syntax that pretty much everybody who's been doing work in this industry in the last 20 years knows how to write that SQL query, and so it can ask these big questions and it answers back relatively quickly and process a terabyte of data in 42 seconds. So that's BigQuery. So with that, I am going to kind of run down and conclude and make sure I have time for questions. But basically, that was a quick overview of a couple things at Google Cloud Platform. I picked 3 very specific pieces: App Engine, storage, nearline storage, and BigQuery. If you brought in one of my colleagues on the team who has a different focus, they probably would have talked about 4 different areas. If someone was a big data person, they may talk about data flow and Bigtable and Container Engine and PubSub more. Someone else might say data store plus compute engine plus load balancing allows them to do crazy things. But at the end of the day, you have to ask the question, like, can this platform support my work? Can it do what I need it to do? The answer is yes. Cloud Platform is the same technology that's running Google. We can accommodate what you want to do. There are some places where we have a competitive advantage, and we pass that competitive advantage on to you, like processing data with BigQuery, like storing data cheaply, sort of nearline, like scaling infinitely with App Engine. But there are a number of these things that we have, and any one of my colleagues will come up with maybe different answers for what they think really highlights cloud platform best. But whatever you're doing, we certainly can host you. And so basically, all of this massive infrastructure that we have, we run through Google Cloud Platform, and you can take advantage of it. And it's what we use to run our moonshots, right? When we have a crazy idea, we can do it, and we have confidence that we can do it because we're confident in our infrastructure. And that can be the same infrastructure that powers your apps and your tools and your technology. I'm going to open up for questions in a second. But if you want to find out more, you can contact me at terrenceryan.com or on Twitter at tpryan. And this Prezzo is available bit.ly/tpryan-GCP. Sorry, I couldn't get a better short acronym for it, but hopefully that's close enough. And I'm going to fire up the rest of the interface here and see do we have questions or what's going on.
I haven't seen anything come in through Twitter or through the hashtag yet. I'm sure there are questions. Right now, I'm not even sure what I don't know to phrase a question appropriately. Like BigQuery is incredibly impressive, as is App Engine. Where was I heading with that? Is there, like, that's pretty well the fundamentals of those three. Is there like, what question should I ask at this juncture?
That's a good question. So is there more, right? And so I know this is the first of a series of events. So I know some of my coworkers on the Google Cloud Platform Developers Advocates team will be here. So you're going to find out deeper into big data, and you're going to find out deeper into computing and deeper into storage. So I sort of, they're going to tell those stories more completely. My job is just to show you some cool stuff to get people to come back,
Okay. Sure. Speaking of storage, we have storage on June 9 and compute on June 2, and then we take a detour into data stores on the 16th, and what was it? It looks like we're back at compute again on the 30th. Is there a difference between, say, compute continuum or? Yeah, so I've got one for compute engine and one for compute continuum. Are those two different things, the same thing?
They probably compute engine will go deeper, and I'll talk with my colleague. But compute engine will go deeper probably into compute engine, which I'm sorry that seems sort of not really that helpful based on that. But the compute continuum, it basically probably talks about the whole spread from
from soup to nuts.
App Engine on one level is platform as a service, right? You don't tweak anything, and then you've got Compute Engine, which you get access to a VM, and you can do anything you want, but you have to maintain it. And, if you want to set up scaling, you can set up scaling, but you have to set up scaling, right? Whereas with App Engine, you don't. So those are the two extremes of what we offer. And then in between, we have a number of technologies. Managed VMs, which sort of bridge the gap between those two. We also have Container Engine, which isn't on that continuum in the sense of, like, you want to bring a whole bunch of stuff online and make sure it runs permanently and is always available. Container Engine it's based on Kubernetes. It's the sort of solution for handling that sort of thing, which also, is part of that computing continuum, because basically it allows you to not auto-scale, but basically say, I would like my environment to look like this. And if it ever doesn't look like that, it'll spin up a new node. If one of your nodes goes down for whatever reason, one of your containers goes down because you have a bug or just too much load or something, then Kubernetes will spin up another one, and you don't even have to worry about it. So that's sort of what I would think would come up with in that Prezzo. the team, the group of guys that work on that, I mean, we all work closely together, but we're not in the same office, so I have no idea what they're actually planning on showing for that one. That would be my guess based on the description.
Okay. So other generic questions then. Like this is all very public cloud, and that's very nice. Are there components of this? Like if I were to have the infrastructure, would I be able to run some of this internally? Is any of this open sourced? You know, is there outside of the network connectivity piece, is there a private cloud aspect to this, or is that even something, you know, is that even relevant in this discussion?
So the answer is going to be a frustrating it depends, right?
Yep.
Kubernetes is an open source product. It's what underlies Container Engine, and so you could set up Container Engine locally, and then, you know, because basically it's based on containers, you know, Docker containers and auto scaling. Because it does all that, you can basically, whatever you write your container in, and locally you can move to the cloud and vice, you know, back and forth. So you do get some sort of that play. But like App Engine, for example, you're going to run that. There is an open source-ish version of it, but really, you're going to run that. You're going to run that on us.
Okay.
And then you can hook up VPN between your on-prem stuff and your cloud setup.
Okay.
But you can't run BigQuery locally, for example. You're going to have to run that in our cloud.
That's perfectly understandable. Next up on the list was you know, generically the InfoSec question, and, you know, like, is cloud secure? And, you know, like, we've all kind of grown accustomed to yes, and the providers are generally a little bit better at it than we are, at least in some ways. Not all providers are better at all things. So a couple of questions down that path.
Sure.
Am I able to extend my internal authentication systems out to Google Cloud, or vice versa? Can I federate those back in? And then the data sovereignty question. You know, like if I upload something generically to BigQuery, right? Is there a way to guarantee that that is hosted in a data center that has data sovereignty policies, data sovereignty, you know, that are respectful for, yeah.
So first off, I will plug that just today we unveiled a site that sort of answers a whole lot of our security questions. Called cloud.google.com/security. And I bring that up because basically I'm going to say some stuff, and we might have better, more accurate, more up-to-date answers on that site. So I would just say, if anything I say here is contradicted by what's on cloud.google.com/security, that they are right and I am not. That's the first thing I'll say. Second thing is federated authentication. Yes, to an extent. It really depends on the setup, but there are people that are running federated authentication. But again, it's really going to depend on what you're actually doing, and you know,
okay.
It is possible, depending. The next question was data sovereignty. So we do at a high level deal with the fact that, you know, if you're in Europe, your data has to be in Europe, those sorts of issues. But deeper than that, you'd have to check cloud.google.com/security. BigQuery specifically, I know the rest of them you can put wherever you want. You can make sure storage is where you want it, with certain levels of granularity. And I want to say for most of the services, it's, you know, I want to be in Europe, I want to be in the U.S., or I want to be in APAC. But country to country, it's going to depend on the service, and I think for the most part we don't go that granular. But again, anything I say there could be contradicted by cloud.google.com/security, which came out while I was prepping for this talk, so I didn't have time to go through and study all the answers. So I apologize for that.
Hey, no worries. I went ahead and sent that link out already. And we do get into to BigQuery in more depth on July the 14th, it looks like. So we're going to be all over the map. that sums it up for questions for me. I haven't seen anything else pop into the tweet stream, and unless everyone is furiously typing away, I think that does it for us. I'm going to give it a couple more seconds.
All right. Well, thank you very much for hosting. I hope this was at least helpful, at least sort of slake some curiosity, or not slake. I want to stoke curiosity. That's what I want to do.
Yes.
I want to stoke curiosity for Google Cloud Platform. It really is. It's exciting to work with it, and the fact that we're powering other developers to do cool stuff is just awesome. So I want people to go out and use it. I want people to find problems with it, report them back. So, please, if you have any questions, reach out to me and at TPRyan on Twitter. I do have TweetDeck looking at the Brownbag list, the hashtag. So I'll watch it for a couple days closely. And yeah, thanks very much, guys.
No worries. I guess with that, I'm going to cut the recording. Thank you, everyone, for coming.